So I was asked to put together a video that looked at quadrilaterals as part of the coordinate geometry section for A-level maths, because when you get to exam questions for coordinate geometry, quite often they will involve a quadrilateral because they're quite a straightforward shape to work with and to make a question out of. Now, it could be a kite, it could be a parallelogram, it could be a rhombus, it could be a trapezium, and it's important that you know the properties of that shape. Now, you will have met quadrilaterals initially a long time ago, and you will have learned about the properties of quadrilaterals throughout your schooling, and you may have been tested on specific parts of that as part of the GCSE. Now, when you get to A-level, you're not going to be asked about the properties of a rhombus. You're expected to know that in order to solve a problem. So really I'm focusing on the problem-solving aspects of coordinate geometry questions in the exam. So the best way to do that is to really look at quadrilaterals and think of it as almost like a family tree, so you can see how they are interconnected, and then thinking about what are the necessary and sufficient conditions for each of those shapes. Now, I'm not going to go into absolutely everything because A-level maths doesn't tend to be a lot of find the missing angle, okay? Although angles obviously are important in A-level maths, we don't do a lot of that. So a number of the circle theorems, you know, we don't deal with in A-level maths. So I'm not going to go through absolutely every property, but I hope that this kind of overarching view will help you tackle those coordinate geometry questions that involve quadrilaterals in the exam. So let's just say we drew a random quadrilateral. Here we go. Let's have there and then there. So here is a quadrilateral, okay? But this has really got nothing special to it. It doesn't have any sides the same length. It doesn't have any sides that are parallel to one another. So essentially that quadrilateral could include anything that looks like that, plus all the ones that we know the names of, okay? So what I'm going to do as we work our way down, okay, is we are going to add in specialized features, okay? So the first specialized feature that you might include is to have one pair of parallel sides. So one pair of parallel sides. Now, if you do that, we're going to get to the trapezium. Okay, so trapezium, of course, is a special type of quadrilateral. But the thing about trapeziums is that they can look quite different from one another. So here is an example of a trapezium. Okay, and those two sides are parallel. But you could also have one that looks like that. So those two sides are parallel, and they could be right angles, for example. Okay, both of these are trapeziums. Okay, but a trapezium just requires one pair of parallel sides. Okay, so that is a necessary and sufficient condition. you could say that it has the property of one pair of parallel sides. Okay, so it has that property, and that is enough, that is sufficient to then call it a trapezium. So, what happens if we then add in a second pair of parallel sides? So 2 pairs of parallel sides. Well, then we have a parallelogram. Okay, so parallelogram, 2 pairs of parallel sides. Okay, so let's say we've got one there and one there. Here is an example of a parallelogram. So those 2 sides are parallel, and those 2 sides are parallel. Okay? Now, once we've got the parallelogram, because of it having 2 pairs of parallel sides, it's got also 2 pairs of equal sides. Okay? We can't draw one without it also having that property. So we also know that that side and that side are the same length, and this side and this side are the same length. Okay? Right, so that means also from our family tree that a parallelogram is a special case of a trapezium. Okay, so it is a trapezium with the added feature of having another pair of parallel sides. Okay, right, okay, so now from the parallelogram we branch off in 2 different directions. Okay, because in order to make the parallelogram more specialized, what I could do is I could now say that all of the sides are the same length. So all sides the same length. Now if I make a parallelogram, have all sides the same length, then we get a rhombus. Okay? Now, your rhombus, let's see. Now, this is going to be a little bit more tricky to draw. I will do my best. Now, well, I'm going to go off the board. No. Let's try again. Well, I'm just going to have to make it a little bit steeper. It's a little bit better. Good enough, I reckon. Good enough. Right, okay. So, this side is parallel to this side. This side is parallel to this side. And all sides are the same length. Okay? And so that is your rhombus. Now, how could I make the rhombus more specialized? Well, I can make the rhombus more specialized by making all of the angles the same. Now, of course, one of the properties of a quadrilateral, you know, if you just draw a quick quadrilateral down here, okay, is that any quadrilateral is angle sum is 360 degrees. All the internal angles add up to 360 degrees. And that's because if you split it, you can split it into 2 triangles, and each of those has 180 degrees. Okay, so your 3 angles there is 180, and then 3 angles there must be 180. So in total, it must be 360. Okay, now if all the angles are the same size, then you've got 360 degrees divided by 4, which is 90 degrees. So we can specialise the rhombus by making all angles the same, so equal 90 degrees. And of course, we would have the square. Okay? So the rhombus, so let's start from the top, right? The trapezium is a special case quadrilateral. The parallelogram is a special case trapezium. The rhombus is a special case parallelogram. The square is a special case rhombus. Okay? Now, if we go back to the parallelogram, then we branched off saying, well, we could make all sides the same length, and then all angles the same. If we did that in reverse order, if we did all angles the same, so 90 degrees, so if all our angles are 90 degrees, then we would have the rectangle. Okay? And then if we make all the sides the same length, then we have a square. Now, there is one special type quadrilateral that I haven't got written down on the board yet, and that is the kite. Now, the kite is not a special case trapezium. Okay? So the kite is essentially out on its own, but it does share some of the properties of another shape that we have on here, and that is the rhombus. Now, if we try and draw a kite, I'm going to try and draw one here. We will see how this goes. Let's see. Let's have it something like... Might not be the most perfect of kites, but it will do. What properties does the kite have? Well, it's got two pairs of equal sides. So two pairs of equal sides. Okay, so essentially it has, in fact, you might say, well, the rectangle has two pairs of equal sides as well. Okay, and so does a parallelogram. So it does have that property, but those sides are not like opposite one another. Okay, so they're not quite the same. But it does have two pairs of equal sides. But how is it related then to the rhombus? Well, the kite has a useful feature, and this is one that people often forget about at A-level, in that if I draw on the diagonals of your kite, then those two lines meet at right angles. Okay, and that is a very useful feature. So how does that link in with the rhombus? Well, rhombus 2 has that same property. Okay, so the kite and the rhombus have the similar property of their diagonals meeting at right angles. Okay, and that is particularly useful to know as part of coordinate geometry problems in the exam. Okay, so let's think about necessary and sufficient conditions when we talk about these quadrilaterals. So, we all know what a square looks like. That's why I didn't bother drawing it. And the same with a rectangle, okay? So, for a square, I know that all angles have to be the same, 90 degrees, okay? That is a necessary condition for the square. However, is it sufficient? So if I said, I have drawn, so let's say I've drawn a quadrilateral on the board behind me, you can't see it, okay? And I tell you all of the angles are 90 degrees. Does that mean it is definitely a square? No. You know that it would be a necessary condition for it to be a square. However, it is not sufficient to be a square. So in order for it to be a square, all the sides need to be the same length as well. And it must have two pairs of parallel sides. Okay? But that essentially you could read off from the fact that you have both of those conditions, right? So, although the square requires two pairs of parallel sides, it has two pairs of parallel sides, all sides the same length and all angles the same at 90 degrees covers that. Okay? As for the rectangle, let's say, again, if I'd drawn a shape and I said all angles the same at 90 degrees, you'd probably be saying, right, it's either a square or a rectangle. So I need another bit of information. So it's necessary that the square and rectangle have all angles the same at 90 degrees. But they are not sufficient conditions. I need to know something else. So if all sides are the same length, then it's a square. If not, then it is a rectangle. Okay? So in some cases, you may find that an exam question utilises a kite, or it might be you're utilising the fact that 4 points form a rhombus, or 4 points form a parallelogram, and when you approach those types of questions, okay, for the kite and for the rhombus, of course, utilising the fact that the diagonals cross at 90 degrees may well be an important facet of that question. If you have three known points, so let's say this is a question I've seen before, let's say you've got three known points, like so, okay? Let's make this fairly straightforward. So let's say that that is the origin. Let's say that this is the point 10, 0. And this is the point 2, 5. Okay? Then you might need to find this point here. Now, when you're finding missing points, quite often I like to think of it using vector knowledge. So I think about, right, going along this line, I need to go 2 along and then 5 up. So to get this point, I need to do the same thing. I need to go 2 along and 5 up. So this point would of course be 12, 5. Now that's a very basic example because the parallelogram might be rotated slightly, in which case you might need to use other methods. Okay, you might need to find the equations of these lines in order to solve the problem. Okay, so hopefully this kind of overview of rectangles, of quadrilaterals, not just rectangles, of quadrilaterals has been useful. Just to kind of like bring it back into your mind, because as I said, a lot of this you learn usually before you start your GCSEs, and it's then kind of expected knowledge. And there could be quite a gap between being asked about the properties of quadrilaterals when you first learn it, up until when you do your A-level exam, and suddenly you're thrown into the idea, oh, I've got to work with a kite. What were the properties of a kite? I can't remember. Okay, so hopefully this is bringing back lots of memories, and it's probably everything here that you know. I would hope that you know, but maybe this kind of like family tree way of representing it will help you think about how to problem solve in the exam.